Sampling is an act of collecting samples to produce meaningful information. The ease or complexity of sampling will depend on the nature of the sample. It is a process to get a representative and homogeneous sample. Representative means that the content of analytical sample reflects content of bulk sample. Meanwhile, homogeneous means that the analytical sample has the same content throughout. Liquid sampling, the precise collection, handling and preparation of representative samples of liquid compounds for analysis is a critical step in analytical chemistry. This step is vital for accurate and dependable results in many analytical procedures that need the exact measurements of sample substance. The sampling method chosen is determined by the specific analytical method and sample parameters. Gas sampling. Gas sampling is conducted for a wide range of purposes, including environmental monitoring, industrial process control, quality assurance, and research. The collected gas samples are analyzed to determine the concentrations of specific components. Lastly, we got solid sampling. Solids are the most difficult to sample because they are heterogeneous systems. The particles are made uniform by crushing and grinding. So, the modern techniques for solid sampling includes accelerated extractions, supercritical fluid extraction, and microwave-assisted extractions. Soil sampling entails collecting representative samples from a specific area of soil for further analysis. Soil sampling also is to determine the chemical compositions of the soil, including the presence and concentrations of various elements, nutrients, pollutants, and other compounds. This data is useful in environmental monitoring, agriculture, land use planning, and other industries where soil quality and health are critical.
The objective and purposes of this study are to give the information regarding the soil's organic matter content, to identify the soil essential nutrient level, to maintain and adjust pH levels, to evaluate the soil physical properties, to find out if there are any pollutants present in the soil, and lastly, to assist farmers in implementing effective strategies for planting. Let's look at the importance of soil sampling. Why do we need to properly collect soil sample? Here, why it is so important. Firstly, for accurate soil analysis. The quality of soil analysis depends significantly on the quality of the collected sample. Where collected sample provide precise information about the soil nutrient level, pH, organic matter content, and potential contaminants. Accurate analysis guide farmers in making informed decisions about fertilizer application, soil amendment, and other management practices, optimizing crop growth and yield. Secondly, to ensure consistent monitoring. Properly collected soil sample provide a basis for consistent monitoring of soil health over time. Regular sampling at interval allow farmers to track change in soil property and make necessary adjustment in agricultural practice. This continuous monitoring helps prevent long-term soil degradation and ensure sustainability land management. It is also important to protect the environment. Proper soil sampling also contribute to environmental protection. Accurate assessment of soil health and contaminant level allow for targeted and appropriate remediation effort. This prevents the unnecessary spread of pollutants, protect water sources from contaminants, and promotes environmentally friendly agricultural practices. It is also important to know how often we should submit a soil sample. The frequency of soil sampling in agriculture depends on several factors, which is crop rotation and variability. Different crops have varying nutrient needs. If you rotate crops or have different types of crop within the same area, it might be beneficial to sample the soil more frequently to understand and accommodate this varying requirement. Next, when implementing significant change in soil management practices, such as applying new fertilizer strategies, introducing cover crops, or altering irrigation method, more frequent sampling may be necessary to assess the impact of these changes on soil health. Soil properties can change slowly or rapidly depending on various factors like weather condition, erosion, organic matter decomposition, and microbial activity. Soils that are prone to rapid change may require more frequent sampling to monitor this fluctuation. Lastly, historical soil test results can guide decisions about the frequency of sampling. If there is consistent stability in soil properties and crop performance, less frequent sampling might suffice. As a general guideline, soil sampling is often recommended every 2 to 3 years. However, it is crucial to consider the specific need of your agricultural operation. Soil sampling provides numerous advantages in agriculture and environmental management, including optimizing nutrient management. Soil sampling provides essential information about nutrient level in the soil, including nitrogen, phosphorus, potassium, and micronutrients. By understanding these levels, farmers can precisely tailor their fertilizer application, ensuring that crops receive the right amount of nutrient. This optimization boosts crop health and yield while minimizing excess nutrient runoff, which can harm surrounding ecosystem. Secondly, improve crop quality and food safety. Healthy soil lead to better quality crops. Soil sampling help ensure that the produce grown is nutrient-rich and free from contaminants. This is not only enhance their quality and taste of agricultural product, but also contribute to food safety by reducing the presence of harmful substances, benefiting both consumer and producer. Next, compliance with regulation and standard. Soil sampling is in compliance with environmental regulation and agricultural standards. It helps farmers monitor soil condition, assess potential risk of soil contaminant, and take measures to meet regulatory requirements, ensuring sustainable and responsible farming practices. Last but not least, to ensure cost efficiency, soil testing offers a cost-effective approach to agriculture. By providing precise information about soil characteristics, it helps farmers avoid unnecessary expenditure on excessive fertilizer or treatment. Instead, it allows for targeted and efficient use of resources. In the long run, this cost efficiency contributes to increased profitability for farmers while reducing the environmental impact associated with excessive chemical use.
The theory behind soil sampling in agriculture is grounded in the principle of precision agriculture and soil science. The processing involves systematically collecting soil sample from a field to analyze various properties that influence plant growth. Sampling technique includes choosing suitable sampling strategies to guarantee accurate and representative results. Next, sampling size recognizes the significance of a sufficient sample size for obtaining accurate results. Laboratory analysis focus on the significance of using reliable laboratories and standardized analytical techniques to guarantee results that are accurate and consistent. Data interpretation understand the necessity of the interpretation soil test result with consideration of particular plant requirement, soil properties, and environmental factors. There are a few steps to collect soil sample. First, separate the area into zigzag parts. Second, remove any surface layer with a scraper. Next, digging a V-shaped hole to collect soil sample. Then, gather soil from the V-shaped hole's exposed sites. Lastly, proceed to the sample preparation process after gathering soil. For conning and quartering, first, a sample was spread out, then mixed thoroughly into conical heap. Then, sample was separated into a quarter. The quarter is repeated a few times and the sample was placed in a sampling bag. The equipment used for soil sampling is first, soil push probe, hand auger, soil corer, trowel, shovel, and also sampling bag. This is the preparation for the soil sampling. Firstly, we need to choose sampling area and make V-shaped cut that goes down 15 cm. Then, take a sample with the auger after driving it to a depth of 15 cm. Thoroughly mix the sample and remove trash such as roots and stones. After that, divide the well-mixed sample into 4 equal parts to complete the quartering process. The remaining quarter are combined after 2 opposing ones are discarded. Next, take the sample and place it in a sampling bag. Label the soil with the necessary details and soil sample is ready for a laboratory test.
Soil sampling is crucial in precision agriculture, enabling farmers to select suitable crops for diverse field conditions, optimize crop potential, and address soil-borne diseases and insect concerns. It aids in data-driven decisions for sustainable resource usage, crop health enhancement, and productivity increase. As for the results, resource efficiency affect variable rate application of inputs based on soil analysis, and data-driven decision-making helps optimize the use of resources. This leads to reduced waste and more sustainable farming practices. Second, by precisely applying inputs only where needed, farmers can reduce overall input costs. This includes savings in fertilizers, pesticides, water, and fuel for machinery, contributing to improved profitability. Lastly, tailoring irrigation schedules to specific zones based on soil moisture levels, farmers can conserve water, reduce energy costs, and prevent over-irrigation. Soil sampling is crucial in precision agriculture, enabling farmers to select suitable crops for diverse field conditions, optimize crop potential, and address soil-borne diseases and insect concerns. It aids in data-driven decisions for sustainable resource usage, crop health enhancement, and productivity increase. As for the results, resource efficiency affect variable rate application of inputs based on soil analysis, and data-driven decision-making helps optimize the use of resources. This leads to reduced waste and more sustainable farming practices. Second, by precisely applying inputs only where needed, farmers can reduce overall input costs. This includes savings in fertilizers, pesticides, water, and fuel for machinery, contributing to improved profitability. Lastly, tailoring irrigation schedules to specific zones based on soil moisture levels, farmers can conserve water, reduce energy costs, and prevent over-irrigation.
To summarize, soil sampling is an important agriculture practice that provides valuable information to farmers, agronomists, and researchers. Understanding the pH balance, nutrient levels, composition, and possible contaminant in the soil helps to guide intervention like fertilizer application and irrigation technique. Additionally, it aids in identifying hazards like deficiency in nutrients and soil erosion. As technology advances, it becomes more accurate, efficient, and cost-effective. Adopting the principle of soil sampling enhances agricultural productivity and helps to create a more sustainable and healthy future for the next generation.